Hi guys, welcome to Learning Electronics Repair and the amazing $1 in-circuit transistor MOSFET thyristor tester. Yeah, this is it. You see it on the bench now, lashed together. So let's have a look to see how this actually works. We'll draw the schematic, yeah. Let's figure out if we can really build this for $1. And then let's put it through its paces. So this device will test transistors, MOSFETs and such like in circuit. It won't work in every occasion. We will talk about where it may not work, but it works in a lot of cases. So we can see it tests the wide range of semiconductor devices, the ones we're most commonly going to come across. It will also test both enhancement and depletion MOSFETs, by the way, although almost always the ones we find are enhancement. It may test some other devices I haven't even listed here. Yeah, so you guys let me know what you think later. So let's draw the schematic for this amazing piece of tech. Let's see what it is, what it does, and then let's try it. The first thing we have is the multimeter. In fact, we have two multimeters. Now, I'm not including these in the $1 because, to be honest, if you're thinking of building this, you're into electronics repair and such like. Anyway, you're going to have a multimeter, and almost all of you will have at least two, if not more. They don't have to be anything special, as long as they have a diode test mode. That's all we really need. So let's just put the multimeters on here first, okay? The first one we're going to call trigger. Yeah. I know it sounds like somebody out of an old sitcom, but there you go, yeah. Or maybe something off the Lone Ranger for that matter, I don't know. So we have trigger, or T, okay. And the second multimeter, we'll have a much more sensible name. So this one is measure. Or M, okay, T and M. And each one has a red connection and a black connection, as we find on multimeters, okay. Like so. I've drawn them differently because they're probably two different sorts of meter. That's my excuse anyway. So the other thing we have is a switch. Now this is a 4-pole double throw or changeover switch. I didn't have one, so I just used some switches I had lying around, which are double throw. I used two of them. If you really want to spend some money on this, you could buy something like one of these. You want the 4-pole 3 position, although you're only actually going to use 2 positions. You won't need the other position. Or you could buy something like this. This is a changeover. They do an on or an on-off on. We want the two-way, so it's just on one way and on the other way to the other pins, okay? But you could use that one and ignore the sensor position, again, whatever you have. And there we have a 4-pole changeover switch. So you could use either of those, or you could just lash this together. I'll show you how I did mine in a moment, okay? So spending that money is optional. The switch then, 4-pole. So I'll draw them here and I'll draw them here. Okay. This is a changeover switch. And we have 2 more poles. Okay. Like so. Fit them on the page. So these are all ganged together, as they call it, a 4-gang switch. So when you move to one position, they all go into the up position, and you move the other way, they all go into the down position, okay? Now let's connect our multimeters. So the red lead from the trigger multimeter can go here, okay? And the black lead can go here. And this is one of our test leads. These are all our test leads. And this one we will call T, trigger. Okay? In fact, we'll call it trigger. The same with the measure multimeter. So the red lead goes to here. And the black lead goes to here. And this is our second test probe. And we'll call this measure. And then the last two switches, we connect these together. Like so. And this is common. This is our third test lead. So we have three test leads: common, measure, and trigger. Okay. And from these here, now we make sure we get this the right way round. So in the up position, let's give them some names. This is trigger red. This is trigger black. Okay. Red is in the up position, again with this one. So this is measure red lead, measure black lead. Okay. And then we want to connect this the opposite way round. So when the trigger and the measure are both on the red, we want both the black leads to connect here. So we have one from here. And the other one comes from here. Okay, so this is measure black, the same as that, and this one is trigger black. Doesn't actually matter which way round, because when the switch is switched here, they are connected together. Okay, we have two more wires, and they're hard to draw, so we're going to use nets. So trigger red also goes here, from trigger red. And measure red also goes here. Again, it doesn't matter which way round, because when the switch is in the down position, both the reds are connected together. So in the up position, trigger is connected to the red input on this meter, measure on the red input on this meter, and common is connected to both the blacks. Okay. In the other position, trigger is connected to the black lead on this meter, measure to the black lead on this meter, and now both the reds are connected to common. So this reverses the polarity, and what this switch does is it switches between NPN or N-type for MOSFETs and PNP or P-type. So that's what that switch does, it selects the polarity. Now, I said you could buy some switches, or you could do what I've done. And I've used this. It's just off a scrap piece of equipment. I took the switches off. So these are just double pole changeover switches. These two are not used. I have two. So on mine, pushing both of them in, that is the same as pushing all these down. That is the PNP position, and that is the NPN position. Yes, you can operate one or the other individually, but it has no meaning. They're either both out or they're both in. Okay. So that's how this is wired. All this little lash up of wiring here is just that. I actually drew a picture of this. This is while I was actually developing this and working it out. So you see the same symbols: trigger, measure red, trigger, measure black. And I have coloured wires, red, yellow, black, blue, and you can see they're all kind of spaghetti-ized. Yeah, is that a word? Spaghetti-ized? Something like that, yeah. Spaghetti-ized? Not sure. And these are my probes: trigger, measure, and common. And that, with all those coloured wires here, is what you see. You'll notice I've taken some of these banana sockets and connected them to the switch, so I can plug these banana plug leads in, and they go to the multimeters. Can you buy these for $1? No. Do we have to do it this way? No. So for example, if you have a few broken meter leads, and who doesn't? Yeah, and it's normally the probe end that gets broken, we all know that. Then you can take some of these broken meter leads, cut the probe end off. you still have the banana plug on the other end for your multimeter, and you can solder the wires directly to the switch. So again, you can basically do that for free. I'm sure you've all got some old broken meter leads lying around, or for that matter any other sort of wire. Lash this up in any way you wish. Okay, so now we know how this is built, and the minimum cost is basically 4 broken meter leads and 2 scrap switches, or even 4 individual changeover switches and switch all of them. Yeah, you could really build this for nothing. Yeah, but anyway, we'll call it the $1 tester. Now let's put this through its paces. So we'll take the multimeter, we'll set this to diode mode. Okay, diode test mode. And this multimeter is T. Okay, this is T. So we're going to use this to trigger the gate or the base of the transistor or MOSFET or triac. Okay, this one also we're going to put onto diode test mode. This is M or measure. Okay, and this we're going to measure between the collector emitter or the drain source. Okay, we have some devices here. So this one is an NPN transistor, this one is a PNP transistor, this is an N-channel MOSFET, IFPFZHDO. This one's a triac. I didn't have any P-channel MOSFETs to hand, but it will work just the same by switching the switch for NPN PNP is the same for N and P channel MOSFETs. Okay, these are our test leads. So the green one, this is our measure. This is measure. Okay, this one which says T on the end, TTT, this is trigger. Okay, and this is common. Now we'll test some of these components out of circuit, and then once we familiarize ourselves with this, let's test some in circuit. This I happen to know is an NPN transistor, so I have both the switches, yeah, in the out position, NPN or N type. Let's see. So what we need to do is hold the probes like this. This is very easy. I hope when you guys go for Chinese food you use chopsticks. Yeah, you should do, because you'll learn very useful skills. But basically, I'll put the common on the emitter. Okay, I'll put the trigger on the base and watch the multimeters. So trigger is showing 0.612. That's the forward voltage drop on the base. And measure is showing 0. That's the resistance of the transistor when it's switched on. Okay, so that was an NPN transistor. Let's try a PNP transistor. So in this case, we'll switch it to PNP. In fact, I'll tell you what, let's switch it to PNP and try the NPN so you see what happens. So both the switches in. We'll try our NPN transistor again. Okay, so measure on the collector, common on the emitter, collect the trigger. Nothing happens. Okay, because the NPN transistor won't work at that polarity. Let's try the PNP transistor. So collector, emitter, base. Now it switches on. Okay, don't think that this red lead is the positive end. It depends on the position of these switches. This is just your trigger lead. Okay, so there we go. This is an N-type MOSFET, but let's try it in the P-type position. So we go drain source. Okay, connect the trigger. You can see we've got a reading on this one, but when we connect the trigger, nothing happens. Okay, let's switch the switches the other way. Okay, so the switches are now switched the other way. Try it. And it turns on. Now you'll notice that this one isn't showing anything. That's because the gate of a MOSFET is basically open circuit, and that's why we know, one of the reasons we know, that this is a MOSFET. There's no gate voltage. The second one, it stays switched on until I put my finger on or put the black lid on to switch it off. Okay, so that's a MOSFET. Yeah. Now let's try this triac. So this is a BT139 triac. What's it do? So I don't know which way around the two are. Main terminals shouldn't really matter. Let's connect the trigger to the gate. And you'll see we read like a diode junction on the gate, like a lower voltage than a normal diode, but it doesn't switch on the measure. So you will find some devices like this. If the triac is sensitive enough, it will switch on. If the meter in current mode, the measure is providing enough current through it, it may switch on. If it isn't, then you'll find some that won't work. Okay, so that is something you will find. But okay, we got 3 out of 4. I'm happy with that. Let's try this in circuit. I'll take 2 completely different circuit boards and we'll try on both. So I'm going to try on an ATX power supply and I'm going to try on a motherboard. Okay, so we'll try some through-hole transistors and MOSFETs, and we'll try some SMD ones as well. Okay, so we'll try the old power supply PCB first. Okay, so this is an old ATX power supply PCB. I don't know if it was working or not. It's a scrap one. We have the 2 high voltage switching transistors here in the power supply. We have probably a MOSFET on the standby supply. These are probably bipolar. And then we have some more transistor devices around here as well. So let's see if we can measure these in circuit. Let's see if we can test them, okay, and see what we can find out. So we'll start first of all with these power transistors. So the standard pin out for these sort of transistors, if we look at them, is base at this end, collector emitter. That's fairly standard for this package. In fact, I say pretty much the all base collector emitter. This is probably gate drain source or gate source drain. Okay, we can see these have the 3 pins then, 1, 2, 3, and this one 1, 2, 3. We know that the end, this should be the base. So let's see if we can test these transistors. So if we think this is the base collector emitter and we think they're NPN, we need the switches in the out position. Okay, and we just connect across the collector emitter. We can see reading just open on both multimeters, so let's trigger the base. There. So we can see that the transistor is switching on. Now it's not going to 0. 0 is not fully switching on, but it is switching on to enough extent that we can see the transistor does work. Okay, let's try the other one. So collector emitter, base. Basically the same. So that's a very good indication. A, we have the correct pin out, base collector emitter, that these are in fact NPN transistors and they do in fact work. How about our MOSFET? So the MOSFET is here. 3 pins, a bit messy. Let's try it. So we'll just, I'm guessing this is the gate at this end. Now that doesn't do anything. Okay, it doesn't do anything. So let's reverse these 2. I don't know which is the drain and source. Let's go the other way around. Okay, what happens? Well, I'm seeing a reading already on the measure. I'm reading 0.577. I'm pretty sure actually that's the parasitic diode inside this MOSFET, and I'll probably have it connected backwards. But in actual fact, I'm wrong. So look, nothing will show up on the trigger multimeter because the gate draws no current. But that MOSFET is switching on and off, or switching between 2 states. So we can say basically the MOSFET is good, and if it's an N channel, which it seems to be because this is in the NPN position, the N channel position, the common is in the middle, so this will be the source, this will be the drain. That's how it looks anyway, but I can certainly say the transistor or MOSFET works. How about these little transistors? So that's actually not a transistor, that's a TL431 voltage reference. You can test these in circuit, by the way. I built a little tester for that. I'll link it to the video description on this one. You can usually test these in circuits with a very simple tester I built. But let's have a look at this one. So there's a transistor here. Now I don't know what type it is. I don't know what the pinout is. Let's see if I can work it out. So I can probe around with my 3 meter leads on this in various combinations with NPN and PNP to try and figure out what the device actually is, but probably quicker, just grab another multimeter and let's just see, figure out what we think the pinout is and then test it. Okay, what I'm looking for here then is try to figure out where the base is and try and figure out the polarity first. As I say, you don't need to do this, you can just try the other tester at random, but you may find this quicker. So our transistor is here, 3 pins in a line. Okay, 1, 2, 3. What do we see? Well, that just shows a region. Oh, that's a diode junction. So one of these is probably the base. That doesn't read the junction. So we'll leave the black here. That doesn't read the junction. Close. Go this way. Yeah, it looks like with the red lead on this end and the black here and here, I see 2 diode junctions. So let's assume this is the base and it's the red lead, so it's an NPN. Let's test it. So if it's an NPN, one of these 2 is going to be the collector, one is going to be the emitter. I don't know which one, so we'll just stick it on. And let's try and trigger it. Okay, so we can see 1.22 on the measure. Oh, look at that. So trigger goes down to 0.678 and measure goes to 0. That transistor is fully switched on. Notice the power transistors didn't fully switch on, but they did switch. So we know that is NPN, this is the base, and it's good. Okay, what else do we have? Another one here. Okay, that's these 3 pins. Again, I'll just try and figure out what I'm looking at before I test it. So let's see. I have, that's not a junction. That's not a junction. Let's go the other way. Base could be easily be in the middle as well. That reads like a junction. And that reads like a junction. So again, it looks like NPN and this is the base. Let's try it. So again, if that's the base, let's guess. Collector emitter. Okay, let's try and test it. So again, we trigger it. Yeah, and it switches on. Okay, it goes like short on the measure, and we see 0.679. So that's another good one. Let's look at the third one. There's one more. So this one over here. That's these 3 pins. What do we have here? Well, that reads different, and that looks like a diode junction, but a bit low. That also reads like a diode junction, but different. So it's looking like this. Could be the base. What else do we have here? Anything else? That looks like a diode junction. That looks like a diode junction. So this is kind of showing me diode junctions everywhere. Okay, so I can't test that particularly in circuit. Let's try with our tester and see what it says. So I'm thinking the base is probably one end or the other, but I don't know. Let's see. So let's go this way round. Okay, with a common to the end one. Will it trigger? No, it doesn't. Look, the measure is still showing open. So, although I get a reading on the trigger, that isn't it. Let's go the other way. And it could be a PNP. So let's try this. Let's look on this way and this way. Okay, try trigger the other end. That's it, look. So it's not switching fully on, but it's switching partially on. And that's the right way round. So with the conflicting diode junctions, that's other stuff in the circuit, we can still trigger that transistor to switch on. So that is definitely one up for this, yeah. Let's try a few SMD transistors. Well, here's a motherboard. This is actually a working one, I think. Let's see if we can test some of the MOSFETs and other devices on here. So these are MOSFETs and the VRM. Let's have a look. Okay, so I have the common attached to what I think is a source, and this is on drain. So I'm getting a reading in circuit anyway. Let's try and trigger it. And the reading changes, it goes down. And the other one is showing the gate voltage, about 1.3 volts to trigger this one. So we're measuring that, say, power MOSFET. These will be high side on low side. Let's try the other one. So what does this one do? Well, that doesn't seem to turn on. So the high side MOSFETs on this motherboard, at least, it looks like I can't test with this tester. We'll talk about some of the reasons at the end of this video. But just before that, let's try a few of these small transistor or MOSFET type devices, and they could just be diodes or dual diodes in the package. I mean, you know, this package could be a number of things. Let's see if we can make any sense out of them. So normally this pin, if it is a transistor or MOSFET, is either going to be the gate or the base. Okay, let's try this one. So we want to connect our leads across the other two. This is normally the drain or collector. This one, WW1, is probably a diode actually. I recognise that number, to be honest. So I think this won't test as anything, but let's just see. So I'm connected on there. Doesn't do anything. I didn't think this one actually would. Oh, that reads like a short. Yeah, I think these two pins are actually just connected together, and that's just a diode. I'm actually familiar with that component. What else do we have? Oh, this one here, K72. Let's see what this one is. So thinking emitter or source, drain. It reads a reading. Let's try and trigger it. The reading changes, so trigger goes to 1.7. So it's not a diode junction. This is not like a base. This is more like a gate. And something happens on the other meter. Okay, so we can say that as a MOSFET and working. So I'm expecting this one, because it's the same port number, to do the same. Okay. Again, we'll connect on there. Let's try and trigger this one. Yeah, that one does switch on. Fully on, okay, with 2 volts on the gate. Again, we know it's not bipolar. Another one here, that one may well be a diode, actually, the W something, but let's see. So let's connect across here. What does this one do? Well, just before our meter tried to go to sleep, it triggered and switched on. So that one is a transistor because it's reading 0.716 on the trigger. So that's a bipolar transistor. So you can see, guys, that this will test not everything, but it'll test a wide range of transistors and MOSFETs and maybe thyristors in circuit. So let's just talk about the limitations, and I'll pass it over to you guys. The main reasons this tester is not going to work. If we're talking about bipolar transistors, then if we have a relatively low value resistor from the base to emitter, and this is much more likely on power transistors, output stages of amplifiers and such like, then probably you can't get enough current from here to switch the transistor on. You may switch it partially on and say, yes, it functions, but you may not even be able to do that. So in that situation, low value base emitter resistor, it'll probably fail you. But if you know you have low value base emitter resistors, then you can allow for that. You can expect it, okay? With the MOSFETs, if the MOSFET isn't sensitive enough, in other words, the gate voltage to switch it on is higher than this can generate, which is 3 point something, the meter can't generate enough voltage to switch the MOSFET on. You're very unlikely to have low value resistors between the gate and the source. They're not like bipolar transistors, which are like current driven, so you're unlikely to find that. But what you may well have is something driving the MOSFET that is in circuit, not allowing you to put enough voltage on the gate to switch it on. For example, on those high side MOSFETs I was trying to test, I could only get about 1.2 volts onto the gate. That is almost certainly not enough to switch the MOSFET on. And the reason I couldn't get any more is probably due to something in the driver IC that's driving them, that itself is breaking down at that voltage off my meter and just doesn't allow me to put enough voltage on. So that's probably the main reason why you'll find MOSFETs that you can't switch on. Again, you may be able to switch them on partially, like we found on that ATX power supply with the standby MOSFET. But I think if we see in circuit some reaction, so we can see that we have like a diode junction, a base junction, 0.5, 0.6, 0.7, or it's 2 points or 3 point something. It's like a gate voltage on here, and this is partially switching on. We know the transistor is probably working. Okay, you can investigate further, but it's probably working. So that's the situations where it seems not to work. Triacs and thyristors, the large one I had just wasn't sensitive enough, or the latching current, that's the current required for it to stay on, was too high, or the trigger current basically was just too low. So I think it's unlikely you will test power triacs and thyristors with this. Small ones, I think you have more chance, but I think take this with a bit of pinch of salt. It may do, but whether it's good enough at it to help, I don't know. But certainly these, I think it's going to help you a lot. So guys, you've seen it working. Get into the comments below. Tell us the cheapest way you can lash one of these together. I swear you can do this for $1 or less if you have some bits and bobs lying around. I would probably, in fact I will, because I've ordered some rotary and the toggle 4-way switches, and I have some of these banana sockets around. I'll build this into a little box with just the 3 sockets for the leads, labelled trigger, measure and common, and then the 4 connections to the multimeter, the red, black. Hope you enjoyed that. I certainly enjoyed showing you this. I enjoyed effectively putting this together. It was an idea I had. I wasn't sure if it was going to work, and I think it went very well. Okay, so comments down there. Let me know, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now, guys.